This is SkyTour News for November 19th to the 25th. I'm Amanda Curran. November 25th, 1976. Viking 1 radio signal from Mars helps prove general theory of relativity. Viking 1 was the first of two spacecraft, along with Viking 2, sent to Mars as part of NASA's Viking program. On July 20, 1976, Viking 1 became the first spacecraft to land successfully on Mars and perform its mission. Viking 1 held the record for the longest Mars surface mission of 2,307 days until that record was broken by Opportunity on May 19, 2010. Gravitational time dilation is a phenomenon predicted by the theory of general relativity, whereby time passes more slowly in regions of lower gravitational potential. Scientists use the lander to test this hypothesis by sending radio signals to the lander on Mars, instructing the lander to send back signals, in cases which sometimes included the signal passing close to the Sun. Scientists found that the observed Shapiro delays of the signals match with the prediction of the general relativity. The Shapiro time delay effect, or gravitational time delay effect, is one of the four classic solar system tests of general relativity. Radar signals passing near a massive object take slightly longer to travel to a target and longer to return than they would if the mass of the object were not present. The time delay is caused by space-time dilation, which increases the path length. Transmission of the first surface image began 25 seconds after landing and took about 4 minutes. During these minutes, the lander activated itself. It erected a high-gain antenna pointed towards Earth for direct communications and deployed a meteorology boom mounted with sensors. In the next 7 minutes, the second picture of the 300 degrees panoramic scene was taken. On the day after the landing, the first color picture of the surface of Mars was taken. November 20th, 1984. SETI, the Search for Extraterrestrial Intelligence, is founded. The SETI Institute is a not-for-profit research organization whose mission is to explore, understand, and explain the origin and nature of life in the universe, and to apply the knowledge gained to inspire and guide present and future generations. It aims for discovery and for sharing knowledge as scientific ambassadors for the public, the press, and the government. The Institute consists of three primary centers: the Carl Sagan Center, devoted to the study of life of the universe; the Center for Education, focused on astronomy, astrobiology, and space science for students and educators; and the Center for Public Outreach, producing Big Picture Science, the Institute's general science radio show and podcast, and the SETI Talks weekly series. The SETI Institute was incorporated with the 501 California nonprofit organization on November 20, 1984, by Thomas Pearson, the former CEO, and Dr. Jill Tarter. The SETI Institute employs over 90 researchers that study all aspects of the search for life, its origins, the environment in which life develops, and its ultimate fate. November 20th, 1998. The first module of the International Space Station, Zarya, is launched. Zarya, also known as the Functional Cargo Block, or FGB, is the first module of the International Space Station to be launched. The FGB provided electrical power, storage, propulsion, and guidance to the ISS during the initial stage of assembly. With the launch and assembly in orbit around other modules with more specialized functionality, Zarya is now primarily used for storage, both inside the pressurized section and in the externally mounted fuel tanks. The Zarya is a descendant of the TKS spacecraft designed for the Russian Salyut program. The name Zarya, which means sunrise, was given to the FGB because it signified the dawn of a new era of international cooperation in space. Although it was built by a Russian company, it is owned by the United States. The FGB design was originally intended as a module for the Russian Mir space station, but was not flown as of the end of the Mir program. The FGB cargo block was incorporated as an upper stage engine into the Polya spacecraft flown, unsuccessfully, on the first inertia launch. With the end of the Mir program, the design was adapted to use for the International Space Station. Although only designed to fly autonomously for 6 to 8 months, Zarya was required to do so for almost 2 years due to delays in the Russian service module Zvezda. Zvezda was finally launched on July 12, 2000, docking with Zarya on July 26, using the Russian Kurs docking system. This is SkyTour News. I'm